We have learned that by using row and column, we can arrange widgets in horizontal and vertical fashion. But there is a limit on what we can achieve using these widgets. So let's take an example. In this app, we have 3 buttons and they are being displayed in a horizontal alignment. Now, if I try to add 2 more buttons to it and save the app, the layout breaks and we have this yellow barrier that tells us that there is no more space to display all the child widgets. So in such cases where we do not have control over the number of widgets which we have to the row or column, and they can easily exceed the boundaries of the device, we can use the wrap widget. So if I replace the row with a wrap widget for now and save the app, you can see that the remaining views which earlier were not able to fit in the given device width move down to the next line. So by using the wrap widget, we can add as much views as we want as children, and they will wrap on the screen if the area is not enough for them to display. Good thing with the wrap is that we can use the wrap widget with both horizontal and vertical direction. Using the direction property of the wrap, we can change the direction of wrap widget. By default, the direction property of the wrap is set to axis.horizontal. And here, if I simply change the direction of axis to axis.vertical and save the app, you can see that the wrap now behaves as a column and all the child widgets are now aligned in a vertical fashion. So we can use the wrap widget both as a row and a column by simply changing the direction property of the wrap and changing it to axis.horizontal or axis.vertical. And even if I set the axis to vertical and I increase the number of widgets and save the app, you can see that the widgets now shift to a second column when the first column is filled to the bottom of the device. Now you see the true flexibility of wrap widget. Let's get back to the basic example and take a look at some other properties. So right now, even if not visible, wrap widget is only taking the space that is required by its child widgets. So to prove this, what I can do is I can make the wrap widget a child of a container and then add a width and height to the container. So I'll make the width a nice 400 and I'll give the container a height of 200. And I'll also give the container a color of colors.red so that the container boundaries are visible to you. And I'll save the app and you can see that the wrap is taking the space of the container now. And suddenly, all the views move to the top left corner of the container. Now, to change the alignment of all the child widgets of the wrap, what we can simply do is change the value of the alignment property. And we can set the alignment property to wrap alignment.center, and if I save the app, all the child widgets of the wrap move towards the center, and the wrap itself is taking the full width of the container. So by simply changing the wrap alignment to end, I can align all the child widgets to the ends of the container, that is towards the ends of the wrap widget on the horizontal axis. And in the same way, I can change the wrap alignment to space around or space between. And if I change the wrap alignment to space around and save the app, you can see that each of the child widgets is having a space on its left and right hand side. So the alignment property of the wrap widget is a basic equivalent of the main axis alignment of the row and the column widget. And for the cross axis alignment, in case of wrap, we have a run alignment. Yes, this is a strange name, but basically the run is the direction or axis in which the wrap will occur. So basically, if I add 2 more child widgets to the row, and now if I change the run alignment to wrap alignment.center and I save the app, you can see that all the widgets move towards the center of the container because the wrap widget itself is taking the full height of the container. So basically, the run alignment in wrap widget is the equivalent of the cross-axis alignment in the row and column widget. And you can set the same properties to the wrap alignment and change it to space around. We have multiple rows because of the wrap, and each row is having equal space around it. And if I change the space around to start and save the app, all the views move towards the top of the container, and if I change it to end and save the app, all the views move towards the end of the container. And I can change this behavior by simply adding another property that is called vertical direction. So by default, the wrap widget is pointing from top to bottom. So when I change the run alignment to end, all the widgets move towards the end of the wrap widget. And if I change the vertical direction to vertical direction.up, then the wrap will be pointing from bottom to top. So basically, the start will now be the bottom. And if I save the app, you can see that all the views moves towards the end that is now the top of the wrap widget. So I've explained much about the vertical direction property in my last video that was about rows and columns, and I'll leave the link for that video in the description below, so feel free to check it out. So the next property that we can discuss after that is the spacing. So spacing deals with the main axis of your widget, that in this case is the horizontal axis. So if you're laying out the widgets in x-axis, that is by using the axis.horizontal, then the spacing will add a margin to the left and right hand side of each of the child widget. So if I add a spacing of 10 and save the app, then you can see a slight change in the spacing between each of the widgets. And if I increase this to 20 and save the app, you can see that each of the child is now having a space of 20 points to the left and right hand side of it. And in the same way, there is another property that is called run spacing. And by using this property, we can add spacing to the top and bottom of each of the child widget. And if I add a space of 40 to it and save the app, you can see that each of the child widget is now having a space in top and the bottom also. So I can simply prove that by increasing the number of children, that is by copying and pasting the widgets. And if I save the app, so the container is now being overflown, but you can see that each of the child widget is now having a spacing of 20 for the left hand right hand side and a spacing of 40 for the top and bottom. So other than the spacing, the last property that can be useful in a wrap widget is the text direction property. And by using this, we can change the way in which the widgets are ordered in the wrap. So let's come back to the simple example of 3 buttons, and I'll remove all the other buttons. And now we have a basic layout in which we have a button 1 on the start, button 2 on the middle, and button 3 on the end. And if I simply add a text direction property, and if I change the value of text direction to text direction.rtl, all the buttons in the view change their direction, and now the button 3 comes first, 2 comes on the middle, and 1 comes last. So basically, the text direction property changes the direction of the views on the x-axis, that is the main axis in this case. So all these properties are relatively simple, and they're more or less similar to what we have learned in the row and column widget. But their names are quite different in case of the wrap, because in wrap you can change the direction of views according to your own need, and you can make the wrap widget a row by setting the axis to horizontal and change it to a column by setting the direction to an axis of vertical. So I hope you have learned much in this video, and if you find this video useful, make sure to hit the like and subscribe button for more detailed Flutter widget videos coming to Flutter Widget Essential series on RetroPortal Studio. See you next time. Peace.